I will do Leetcode 1863, sum of all subset XOR totals. This question is asking to compute the XOR total of an array. So basically, it's gonna, let's jump right to the example. For example, you're given an array of 1 and 3. So if you take all the subsets to find how many you take n, 2 to the n. In this case, n equals 2, so it's 4 subsets, right? You can say the 4 subsets of 1, 3 are the empty one, just the 1, just the 3, and then the 1 and the 3. Now, the question's asked, okay, I want you to take every subset, compute the XOR, and then when you got the XOR every subset, I want you to add them up, and that's the answer that I want, this one here. So the XOR of empty, which is just basically 0, and XOR of just an individual element is itself. And then the other one is just basically 1 XOR 3, which gives you that number. So you add them up, you get the solution. Okay, so that's the question here. Now, there are different approaches to this. You could try, for example, one approach is find out, compute all the subsets, right? And that's not an easy thing, and that's not very efficient, okay? But you can do that. There are different techniques to go about that. Now, the solution I'm going to do is purely mathematical by analyzing the binary representation of these numbers. So bit manipulation, okay? So let's analyze this. 1 and 3. I know that's going to be 2 to the 2, 4 subsets, if you're curious about the math. Now, if I look at 1, the number 1, in binary, it's like that, right? Remember, 2 to the 0 here, 2 to the 1 for that place, 2 to the 2, 2 to the 3, right? 1, 2, 4, 8. And then if you want to convert to the decimal, you take the binary bit, multiply to the 2 to the power, whatever, add with every one of them. Anyway, let's take the 3 here. What's its representation? That's a 1 plus a 2. So 1 plus a 2. That's a 3. Okay, now let's look at the solution, right? If you do the XOR, they got 6. What's 6 in binary? So 6 is 4 plus 2, right? So if you have the 2 and the 4 here, something like that, right? What I'm gonna do here, okay, interesting. If I shift, right, shift to the right, I have 2 of them. If I shift it one time, I would eliminate that, and I get these here. Now, if I look at these two, do I notice any pattern? Like, I have 1 and 1, that's 1. I have 0 and 1, that's 1. When it's all 0, 0. Knowing from logic, we have what from logic? We have and, we have or. If you know the truth table for, let's say the truth table for or, let me write it down if you're not familiar with logic. Truth table is we write, for example, what's the operation A or B? If you have A or B, a bit. So it could be 0, 0, 0, 1, oops, 1, 1, sorry, 1, 0, or 1, 1. This is the truth table for OR. If you do A or B, it's 0 here, 1, 1, 1. So you need at least one of them to be 1 to be able to get a true value or 1 value. Okay, if you understand OR. Now, you notice we kind of got that here. 1 and 1 is 1. 0 and 1 is 1. 0 and 0, 0, 0, 0, 0. So it looks like it's an OR. Can we validate that? Let's try the other one. You can keep drawing and try another example, okay? So let's see. If you look at this one here, let me scroll down. That's an example here with 3. elements. So if you have 2 to the 3, that's 8 subsets, a bit more tedious to do. But here are all of them here. So if you have those there, okay, we got 5, we got 1, you got 6. Let's look at the binary representation of these. So 5 is 4 plus 1, right? 1 plus 4. Oops. This is the 1. This is the 4. This is the 2. This is the 8. Okay. Now for the 1, it's just like that. For the 6 is 4 plus 2. Now what's the solution, right? The XOR total. They calculated here, right? You would have to go, okay, for the 5, it's 5. For the 1, for the 6 is 6. 5 and 1, you got a 5 XOR 1 is 4. 5 XOR 6 is 3. 1 XOR 6 is 7. And then for all the 3 is 5 XOR 1 XOR 6, you get 2. Add them all up, you got 28. Okay, so you got 28. That's 28 here. I wrote it here under total. What's the representation of that? The 28 is basically what? 32 is greater, so it's 16. So where's the 16? Gotta be here, right? 16. So let me put another 0 here. 16 plus 8 is 24. So 28 would be what? Anybody wanna? What's 28 in binary? Okay, let me show you something. If you don't know how to do it, just use your programming language. Maybe open the browser. 28 to string. I think you can do, can you do binary or something? Python, somebody could do it. Anybody know? Is it 2? Do I have to say 2 here? There you go. That's the representation there, right? So with that in mind, 1, 1, 1, 0, 0, right? So let me go back here. 1, 1, 1, 0, 0. Makes sense? Now, what I'm going to do here, since I have 3, how can I, if I look at these numbers and I notice there's 0, 0, just like I saw before, for the 2 case, I had 1, 0. In this case, I have 2 because I noticed there's, when it's n equals 2, I have 1, 0. When n equals 3, I have 2 zeros. So if I shift 2 times n minus 1, what am I going to get? I get 1, 1, 1. Something like that. And if you do the ORs, maybe, let me see here. Does that make sense? Basically, what you're going to find, all right, is the XOR total is going to match if you take the OR. However, it's always going to be shifted. You have to take the thing and ignores those zeros. Let me show you here. So basically here, so let's make a variable for the sum, and I'll return something at the end. Let's just keep sum there, but we got to do something about it. Now, if you take those, every number, and you kind of OR them, it's almost the same solution except it's shifted because of those zeros on the right. So what you got to do is bring it, the solution that I compute, you shift to the left to be able to match that. Okay, so do a loop from I0 all the way traverse the array of nums. And then if you OR the map, okay, sum is the sum of nums at I. So this operator here is bitwise OR. You're going to compute all that OR, but if you notice in the output, it's always shifted by those zeros. If I take those zeros, it's always n minus 1 shifted. So here in the sum, let me write down the case here again for the simple one, 1 and 3, right? 1, 3, and the XOR total is 6, 4 plus 2. This is, if you had 1, 1, right, shift it to the right. It's this thing. But if you shift to the left, you get back to this, which is the correct answer. Right? If you do this one, let's do it together, okay? Maybe I take this. Let's do 1 and do the OR. What's the OR between these two? 1 or 1 is 1. 0 or 1 is 1. 0, 0, 0, 0, 0, 0. Okay, so this is the OR. However, that's not the solution, right? Because the solution is 0, 1, 1, 0. Well, what's the difference? The solution is just this number here shifted to the left a certain number of times. So if I were to shift this to the left once, I would get 0, 1, 1, and whatever was there takes a 0. The 0 takes place, okay? When you shift. And this is the answer. I shifted one time. And notice the number of elements is 2. Now let's try to the more complicated one. 5, let me write it here. 5, 1, 6. Let's OR them all up. So what is the 5 again? It's 4 plus 1, right? 4 plus 1. What is the 1? Is just like this. Remember, this is 1, this is 2, this is 4. And then we got the 8 and the 16. What's 6? 4 plus 2. If I OR them all up, what do I get? 1 or 1 is 1, 1 or 0 is 1. 0 or that. 1 or 0 is 1. 0, 1 or 1 is 1. Right? What is the answer? The answer should be 28, right? Remember, 28 was 1, 1, 1. I think, remember the dev tools that I did? What was it? 1, 1, 1, 0, 0. So I got 1, 1, 1, 0, 0. Hey, this guy is this here. However, there's some zeros there. How would I make my OR, the result, match the solution 28? You shift to the left. If I shift it one time, I will get what? This one shifted one time will be 1, 1, 1, 0. Not the same. Shift it again. 1, 1, 1, 0, 0. Now that matches. How many times did I shift? 2 times. How many elements do I got? 3. Do you notice that the shift is always n minus 1? Yeah. So that's why I write this here. You take the sum. To make it match the answer, shift it n minus 1. What's n? Is nums minus length minus 1. After having done the OR, to match the solution, I need to shift n minus 1 times like that. All right, let's see. That's correct. There you go. Let's see. Time complexity. We have a loop. Traverse any times. So O of n. Space complexity. We're not creating a new array. We're just holding the sum in a variable in constant time. So O of 1 space. Hey, thank you for watching. If you like this content, please consider making a donation so I can keep doing this for you. I'd really appreciate that if you could donate. All right, thank you so much, and I'll see you in the next one.